Greetings, statistics friends. This video is to help us understand how to accomplish Chapter 5, Section 1, and this is specifically problem number 10. So in Chapter 5, we're talking about probabilities and probability distributions, and this particular question in Section 1, number 10, is talking about discrete probability distributions. So we have a supermarket shopper program, and we're given that they have an age range of years from 18 to 28, 29 to 39, 40 to 50, 51 to 61, and 62 and over. And then we're told the midpoint of each of those groups. So 23 in that 18 to 28 class, 34 in that 29 to 39 class, and so on. Then the percentage of shoppers that each of those groups have is listed. Now be careful on your homework. This may be different than listed here because these numbers in red are randomly selected. So your second group of numbers may be a little different here. In my case, it's 5%, 41%, 18%, 10%, and 26%. So the first part says, using the age midpoints X and the percentage of super shoppers, do we have a valid probability distribution? Well, the percentage of shoppers, 5% of them of 18 to 28 are in that group. So the probability that a randomly selected super shopper is between 18 and 28 is 5%. The probability that a randomly selected super shopper is between the age of 29 and 39 is 41%, and so on. So if I add up 5% and 41% and 18% and 10% and 26% and I get 1, then I have a valid probability distribution. So I add those up and I do believe that that equals 1. And so the events are distinct and the probabilities sum up to 1. Well, the events are distinct. Well, you can't be 18 to 28, for example, at the same time that you're 29 to 39. You can't be 29 to 39 at the same time, for example, that you're 51 to 61. So those are distinct. So I'm going to click yes, the events are distinct and the probabilities sum to 1. The next answer would be yes, the events are indistinct, so I don't think that's right. And then the third one, yes, the events are distinct and the probabilities do not sum to 1. So they have to be distinct events, which I think they are, and the probabilities have to sum up to 100%, which is the same as 1. So I think A and the first one here is my answer. So then using a histogram, figure out the distribution. Well, 29 to 39 is the big bar, right? So 41% of the people is 29 to 39. So I'm going to look for that one. This midpoint is 34. So midpoint is 34. That's the biggest bar. So it's not this one for sure. It's not this one for sure. And I don't think it's this one, right? Because the biggest bar has to be this second age group. And so I think it is this one, histogram. And then finally, we're supposed to compute the expected age of mu for the super shopper, so that's the expected age. And we're also supposed to compute the probability standard deviation of super shoppers, so this is sigma. So let's look at those two formulas from our book. So the expected value for that probability distribution is the sum of the x's times the probability. So how do we do that if we actually calculated that? Well, let's look at just this first one, this mu. So what I would do is take 23, multiply that by 5%. So 23 times 5%, write that number down. Then I would take 34 and multiply it by 41%, write that number down. Then I'd take 45 times 18%, write that number down. 56 times 10%, write that number down. 67 times 26%, write that number down. Then I would sum all 5 of those results together. So that's how I would do that. So I multiply each midpoint by 5 by its corresponding probability. So 23 times 5%, 34 times 41, and so on. And then I add each of those numbers together. So that's what this means. Calculate the midpoint x times the corresponding probability. When you get all those numbers, this sigma means sum all those numbers up. So that would be my, this is a capital sigma, by the way, this big capital E, which is kind of confusing. This is capital sigma, and then this down here is lowercase sigma. So the capital sigma means to sum things up. So I take each of those, multiply it by the corresponding probabilities, I get the answer, sum them all up, and that'll be my mu, that's my expected value. Then the next thing it's asking me to do is find the standard deviation for the probability. So I take each of the midpoint x's and I minus away the number that I got from the first part, this mu, and I square it. Then I multiply by the corresponding probability distribution. And I do that for all 5 of those groups. So I have a number here, and I, ahead of time for my example, calculated that number to be 46.21. So I do 23 minus 46.21. I get a number, and I square it. Then I multiply it by 5%. Then I write that number down. Then I do 34 minus 46.21, and I square it. Then I multiply it by 41%, and I write that number down. Then I do that for each of those. When I'm finishing doing that, I sum all 5 of those numbers up. And when I'm finished summing all 5 of those numbers up, I take the square root. Okay, so I'm sure you're noticing by now that I actually haven't written any of that down for you. I've just been talking about how to do it. Well, because again, in practice, it would be rare for a statistician to actually do that by hand. And if you are doing it by hand, I guarantee that you are taking your calculator and writing each of those numbers down and plugging them into your calculator. So let me show you how to do it directly in your calculator. So I have my calculator here, and I'm going to go back to the home screen. And remember, once again, for statistics, we're going to use this stat button or this distribution button. One of those 2 buttons are the buttons we'll almost always use in this class. In this case, we're going to do the stat button, and then I have edit list. So in list 1, I put each of those midpoint values. So 23, 34, 45, 56, and 67. I got those numbers from here, 23, 34, 45, 56, and 67. In list 2, I put the probabilities that were given to me. Now notice I didn't put them as a percentage, I wrote them in decimal form. So 5%, 41%, 18%, 10%, 26% in decimal form. 5%, 41%, 18%, 10%, 26%. So in L1, I put the value X I was given, the midpoint value, and L2, I put the corresponding probabilities. So now what I'm going to do is go back over to my stats menu, and I go over to calculate, and I still want the 1 variable statistics. But here in list 1, I put the X values, and that's my X values in list 1. But in the frequency list is where I'm going to put my probabilities, L2. So your calculator probably has that as blank right now. So how do I put that in there? Well, I put the cursor in that spot, and then I hit the second button, and I go down to 2 to put L2. So what it'll do is look at the first row of L1, and it'll look at the first row of L2 and say, oh, those 2 must correspond to each other. Those need to be the same length. So I have 5 things in L1, I have to have 5 things in L2. So once again, if this is going to be blank for most of you, but to put the L2 there, I hit the second button, and then down to the 2, so I get this blue L2, and it puts the L2 there. So I scroll down to calculate, I hit enter, and it lists all of the things that I need. Now here's one thing that happens. By default, your TI-84 calls all mean averages X bar, which is a little short-sighted in my opinion on Texas Instruments point, but that's okay. That's still the mean, and so that answer was 46.21. And so let me go back and show you. That's the mean, 46.21, but that really should be a sigma, not X bar. But Texas Instrument decided just to call everything X bar. And then the other thing you'll notice is this capital S is left blank because that's for the sample, right? And that doesn't apply here. We want the sigma standard deviation for this discrete probability distribution. So that's 14.5. It says to 2 decimal places, so 14.5. Okay, and then I'm going to submit my answer and cross my fingers. Hopefully I haven't made a mistake typing anything in. And it looks like I've gotten all of those answers correct. So if you follow these guidelines, just use your calculator, put the stuff in L1 for the midpoint of X or the distribution or the values of X, put the distributions appropriately for the probabilities in L2, and ask your calculator to compute those things for you. Hope this video helps. If you have any questions, please let me know.